We'll fix it in post.
Yeah, sure.
I'm recording right now.
All right.
So right about here was good, you said? I should have marked it on the floor. I don't know where my little tape roll went.
Yeah.
Oh, perfect. And that way we can know
Probably not farther
than that.
than that.
Okay.
It should be
All right.
place good in the shot.
Well, greeting bears.
Howdy.
This is Squatty Thunder Bear.
Hey, everyone.
I'm Cowboy. So we said we were going to try to go through the math of flat Earth and maybe run some small experiments. So we're doing just quick, dirty, proof of concept, cheap stuff, which I haven't seen anybody else in the community do. So we're actually doing something.
Yeah, we just wanted to go over a couple tests, maybe a couple explanations quick, and then at least get that out there for you guys to look over. Then you guys can critique and let us know what your thoughts are on it.
Yep. Okay, so we're going to go through what we kind of did here. So right now we have a class 2 laser pointer up here. It's leveled, you know, as best as we could level it. Going through this table, through this grid paper. You want to hit the button on the laser. So as you can see, we're sitting at about +6 right now on the x-axis. So what we're going to attempt to prove, and as we slide this back, like we leveled the table too, just so you can see, you know, that's fairly level on this table here. So what we're going to try to prove, so we got what, +6? Yep. So now if I slide this back, all the way back to the end of the table here, and put it back on the y-axis, we're still around 6, you know, within a pretty good margin. So relatively flat for right now. Don't take that out of context, assholes. So what we're going to do is in this space here between our point, the laser end, and the laser, is we're going to introduce some heat source and some cold source to see if that actually moves that laser up and down. And we'll slide that back and forth to see if you can actually map it like this.
Yeah, get a control of nothing in front of it, just the shot with just the laser, the grid, throughout the table, mark some data points, introduce a variable of either heat or cold, move it again, mark the points, add heat right near the source of the light, move it again, mark the points, and we'll see how the results come out after that.
Okay.
See if there's any refraction due to temperature, which could also lead to pressure differences or density differences within the atmosphere of the air.
Right. What we're trying to claim is we're proving the claim that the medium matters, what we're going through, right? So even lasers get affected by refraction by the medium that they're going through.
Correct. Light will have some behavioral changes depending on the medium that it's transitioning through. And our atmosphere is known to not be a uniform medium. So if you're looking a long distance, if you're firing a laser over a long distance observations, whatever it may be, you're not looking through a constant density of air from your eye to the target. So if there's any differences, high pressure, low pressure, high temperature, low temperature, this is what causes, you know, mirages and looming and stuff to that effect. So we're just going to try and do a small scale experiment, somewhat quantify if there can be refraction due to temperature on just a small scale environment.
Okay. So should we just leave this running and do it, set this thing back down, and then pick it up and do it? And then we can maybe edit it later, or we can just post the whole thing.
That'd be fine with me.
So we could edit. There's going to be a lot of downtime, so we might actually edit it out, but we'll have...
Edit it, or maybe fast forward at least between the middle points.
Yeah, gotcha.
Yeah. So, because if anyone's going to cut it, they're going to be like, oh, there's, Your editing
jump cuts.
footage and-
Yep.
Yeah.
Well, what I was gonna say is we could have like the condensed version, and then a longer version if anybody wants it. Yeah, yeah. All right, so where do I want?
This over here so we can observe the.
Yeah, that's a good idea. I mean, we can't really see the, you can see the dot on the paper, but you can't see the numbers on the paper, so we're gonna try to
We'll
zoom
mark
in.
them.
Yeah,
as
we'll
we
mark
go
them and we'll
through,
take a
so
look.
then
So,
We're not
Okay.
gonna change the laser, the target, or anything, and then try and just
okay,
keep that as a control.
sure. So, you wanna do cold first? Well, we gotta do our control first.
Yeah.
So you got a black for control?
Yeah, so I don't know if you wanna,
Sure.
and I'll try and maintain the same exact style
Want
of.
me to tape this paper down here or no? No, that's fine. If I just hold it right here, it'll be okay. Okay. Oops. So, I'm gonna do the center of the laser dot, or attempt to. Try to color it in as about as big as the laser is. Okay. So now we wanna go down?
Say do middle table and end table, so we get
Okay,
maybe 3, well,
sure.
it should be not very,
It should, yeah, it's just gonna turn into one big mark if we do that. One big long mark. How about we just go down to,
you could move, yeah, maybe just do 2. And maybe just make it, half a grid point to the left of it.
yeah, I gotcha, because this is actually, from our mark from our first one,
Yeah,
it looks pretty dang close. Actually, this one looks like it's just a skosh lower. What? Yep, that's good.
okay.
Okay. Well, I'm gonna actually write on there
Well,
forward and back, so we can differentiate
okay.
between the 2 points.
yeah, just put it like an F and a B or something.
Yeah,
like
yeah.
2 points. We got other colors we can use for heat and.
Don't mind my handwriting. Okay, so first test cold, I guess,
Yeah, I think that would be good.
because we're gonna end up, this ice is gonna melt. Okay.
It'd be nice if we could get this as close to at least the height of the laser, so the laser's
Yeah.
passing
Directly
over.
Is that still? Yeah, that's a good idea. Just want to grab a piece of paper here. And, I don't know what to do. Piece of paper. There we go. You got some other good paper right here. Is that better? So,
I can't really see where it is directly over this, so that's why I
Okay.
was kind of wait this maybe it more. Nice.
we're gonna have to put that lighter up on something too.
Yeah.
Close enough? Or is it still too far away from the
I think
beam?
we could try that and see what it ends up.
Well, granted, this is first attempt, like,
Yeah.
a better, was just, like, guys, this was just literally, let's get something fucking in front of
Yeah.
you guys.
Yeah.
And then we can go back
We
and
put this
refine it.
together in maybe a half hour.
Yeah.
Okay, an hour and 45 minutes of that was setup time. And
Yeah,
brainstorming of 15 minutes of how exactly we were going to get this done.
okay.
So, let's see.
So what color are we using for cold?
Use blue.
Yeah, let's use blue. Sweet. Okay. Fire blue, I'm gonna go with, just because we're in Wisconsin and cold is always negative, it's never positive. I'm gonna set us off at the, -3 axis for cold.
First, just put it, once you see comparison with the control where the front mark was, just
Sure.
at least put it over that mark, see if it's,
It's actually lower. It's like dead nuts on 6.
And what was F at originally?
F was probably 6.3 on center.
This way, if we move it over, no one can say, oh, your paper's not level, so you're marking it level. So if we compare it exactly with the mark, even if we move it over, like, well, we compared it exactly
I
with
see
the
what
mark.
you mean.
Yeah.
You want me to transpose it onto the axis.
We don't have to put it on the axis, but at least,
Yeah.
at least show it on the axis, then we can.
Gotcha. Yep. So I'm going to move it over to the -3 axis. This is, whoops, deflected it right there. Right there, as the front. F. Okay, let's move it to the back. I mean, we've already shown some deflection over it. Oh wow, that drops off quite a bit. We're sitting at, like our original back was sitting on center of the laser, was almost dead nut 6. Here we're sitting at about 5.4.
Wow.
So I'm gonna move that over to here.
I'm trying to put as little pressure as possible on the button to
Yeah.
lessen any deviation on the laser pointer itself. So
Yeah.
when I'm depressing the button, that's why you might see it flashing every now and then. I'm just
Okay.
barely getting that
So,
depressed enough to.
what do we learn from that?
Right.
Let's bring it up closer to the camera, or you can bring the camera over here. Let me get some tape to mark where we have the camera set, and then where's my little tape roll? My 1-inch tape roll.
I do not know.
Where the heck?
Oh, here it is.
Okay. Nice. Okay.
Okay.
Yeah, just keep it in the shot, and you can show them.
So you can see the control was in black, F and B for the front of the table, back of the table, and then you can see the blue was when we shot it over ice, front and back, and there is a bit of a deviation just with
A bag of ice.
this
sitting on a
small
table.
amount of ice. So maybe 1.5 foot of distance at least of ice
Yeah,
being
18
introduced.
inches. Yep.
Yeah. So not a very large body of air that's going to be affected by the temperature of this ice. So now if you, just thought experiment, if you extrapolate that over, 20 miles of cool water and your
Yeah.
temperature gradient and between your water and your air, here's your air gun, what we want.
I'm gonna flip my little bin of camera stuff upside down over here, and we can put the lighter on that. Now,
Oh, that's not a bad idea.
I'm not, my little thesis on the heat is it might not be enough heat, right, to actually affect it, but we'll
At least
see.
with the heat, I could even put it close to the laser. I mean, what we could even do is even just move
Yeah,
it
that's
in front,
something.
and then you could just see the effect of heat on the laser. If I just moved it, I don't know if you can see, if I was just to essentially move the laser in and out from the beam itself, or even if you did that.
Right,
If I'm trying to
you're
depress
saying like
this.
the temperature change along the longitudinal from the laser source would have an effect on the deflection? Like if it was closer to the laser source, it would be better?
Just moving here, you can see the laser actually.
Oh, wow, yeah,
Where's
you
the?
can see it wobble.
Here it is.
Keep doing that, I'm gonna bring that camera way closer to observe that. So we're not moving that laser at all.
I am just passing about the flame
Yep.
just near the beam of the laser.
Keep it right there. I got a scale. I'm gonna put a scale on that so people can actually see what type of distance that is. So this is, yeah, you can see this is, focus, focus, buddy, focus. You are not focusing. This is actually a calibrated scale in millimeters. So I'm going to try to hold it up. So each one of these squares is 5 millimeters, right? So I'm going to try to hold this straight. Go ahead and move that. Yeah, that's a movement, a lateral movement of 3 to 4 millimeters. Huh.
It's going just
Yeah.
next to the.
Just to see what's SQTB is doing here.
Squatting Thunder Bear.
Yeah.
Just moving it in and out of, just moving this back and forth, right next to, in, behind, whatever, the beam of the laser.
Mm-hmm.
So and that's causing some deviation. All right, so now we'll see if we can get some
Some data points.
actual
Yeah,
data
back
points and
over.
compare to what we did before.
And then, because I'm guessing right about now, a lot of people are saying like, so the fuck what? Why does that matter? And we'll get into that in a little bit. We got a red. Oh, we got just green. We don't have a red.
Yeah, no, I don't got it red.
Brrr. Okay.
Yeah. This puppy's warm.
Yeah, we're gonna run out of fuel out of that soon.
Okay, so let me see here.
I'm gonna go +3. Well, let's just go right on top of
Yeah,
it.
let me.
It's just slightly higher than the other mark, right?
Okay.
So we're gonna go +3. Whoa. Fucking fat fingers, man. I mean, if you were to go and break each one of these squares up into like 10 gradations,
Yeah.
it might have went up 1 gradation. So
Okay.
up 10%, maybe 20%. So let's move that back. No. Okay, back. Back is lower. Like on
Let me make sure I didn't.
you know what's odd?
Hmm.
I'm gonna bring that camera down here because the laser itself is actually like the dot, the same width, right? Same width, but it's gotten a lot taller. I'm gonna bring the camera down and take a look at that while you're holding that.
Try and maintain the same.
Woo! So you see that laser dot's a lot bigger than the other dots previous. Like I tried to make the laser dot and the ink blot roughly the same size with the center and not take into consideration any of the diffusion, like the lighter or softer rings you see around there. So it's quite a bit bigger. So the heat is causing that laser to actually diffuse out more. We'll mark it now.
Don't set yourself on fire here.
Wouldn't that be some shit?
Yeah, really.
Fill out an incident report. I set myself on fire with the boneheaded experiment we're doing. So we're sitting at about just slightly below the back of the control. Like the back of the control was sitting at 6. So we're sitting at about, at the center point, 5.8, 5.7. Let's move that over. Yeah, that's pretty much dead nuts on. Oh, wow. It's a lot bigger.
I gotta.
Yeah, you get a little warm.
That lighter's getting warm.
Yeah.
Okay, so,
That's interesting.
yeah, I'll bring the camera down so people can see that. Woo! Almost knocked it right over. So if you guys are really not trustful of us, because I'll edit all this crazy, like wobbly footage and try to stabilize the video, but you know, we're fellow bears, so you should be trusting us to begin with. But that's the distribution of it. So you could see right here, we were sitting at about 6.3 for control front, about 6 for control back. The cold caused it to dip, where the front was sitting at about 6 and the back was sitting at 5.5. But the heat also caused this to be slightly higher, the front at about 6.4. Not 6.5, but close to it. And then the back was slightly lower than the control at about 5.8. But these here, these laser dots, as we see, we can go back and show you in the other footage. You can rewind the footage. These were a lot bigger. They were like elliptical shaped like this. So, interesting. I would have thought that we would have saw this come up, like which we did, and then, well, what's that telling us? That's telling us that if the back is lower, the laser is going down like that. Okay.
Well, what could be happening is because maybe because there's such a high temperature from the flame that you're causing a dip and then a fall. I'm not sure, maybe long distance. I mean, it's not
Kind of like that
long.
initial.
I mean, it's not really that long of a test, so
Yeah, it's a 6 foot long table.
that likely, but it's interesting that there was a upward hit on the front of the table and then it was low on the back of the table. So I was kind of thinking of maybe at least trying to shoot the control again, just seeing that throughout the test. We didn't really vary anything.
Okay, yeah, let's shoot the control again. I'm actually going to hold this pretty close to here. So, oops, am I in the way of the laser?
That was me.
Okay. I'm going to move this over.
Is that right about dead on? Looks like from here. That would break.
Yeah, it's close. It's more towards the bottom of the mark, the center of the laser dot. Like the upper part of the mark of the control matches up with the upper part of the laser. I just didn't fill in the rest of that. If I move that over to the front, you can definitely tell that like the heat run of the test, it was higher. And the cold run of the test, wow, was right on 6, where it wasn't right on 6 on here. Like it was a little bit lower. So you can tell the cold for front was lower and the heat was higher. All right, let's go to the back. I feel like I just threw out my back. That sucks. So there's something weird going on here. Am I like leaning on the table? Like our control for our back isn't lining up. Like at all. Oh, where'd the dot go?
I released it a little bit.
Huh. Like the control is slightly lower, the center point for the control is slightly lower than the cold rear, and it's remarkably lower than the hot rear, but it is also lower than the control rear.
Maybe we should do a test too. Second test.
Want to do a second test?
We can maybe try
Okay. What's that?
You're right there.
Yeah. Old, tall. In 23, Rogan's tall. I think it's 23, right? 6'4" is 23? Or is that 22 when some odd change?
There's no such thing as partial Rogans.
There's no partial Rogans?
No, it's only by whole Rogans. So it's probably.
Do you round up or you round?
I'm not sure how the calculator. I think it just rounded. So if it was less than 0.5, I think it went down. If
Okay.
it was over 0.5, it went up.
Okay. See, now the front is a little bit lower. You can really see that. Like matches up with the rear dot perfectly. But the front of the control is not maintained.
Maybe the
a
level
little
of the
bit lower.
battery is causing the laser to diffuse a little bit as we've been using it. I don't know. I have no idea if it would really change that much, or
No, I don't think so.
I don't know what else what would have changed. But let's try and just mark the data points again, quick.
With the
With
control?
black, yeah.
Yeah. Okay. I'm going to push it way out here on the +10. And it looks like it's dead nuts on 6. Stop moving it. You can see the diffusion rings, which is kind of cool. It's not marking it. It's marker not. Ooh, son of a bitch. Marker's dead. Oh, there we go. Oh, you bastard. Okay. Well, we know where it was.
You at least got a partial mark to fill it in.
There we go. Okay, let's try it again. Verify my mark. Weird. Yep. Enough. It's right on there.
Okay.
Front. I'm gonna knock something off here. Trying to line it back up and keep it square.
That's me flickering the laser. I'm just trying to barely touch it again.
Yeah,
So.
okay.
As we're moving it, then I'll try and get this set up again. Maybe this will act as a trough. Okay.
Oh, nice.
Higher.
Yeah. Holy crap. I have to get a document done before the start of shift on third shift, which is gonna happen
If you get
in like an hour.
if you get something done for third shift,
Yeah,
that sucks.
that's what
That's
my
your job.
stuff doesn't, yeah. I run around production, man.
Yeah. Okay, so that's clearing it. I was able to get it a little closer this time, so we can
Okay.
run a second test with that. Try and do it, I think, near the same, near this control. So near the +10 mark, maybe do it
Okay, okay.
+8, +9.
Yeah. So let's put it right on the control and see what happens. So it looks like it's centered directly on the front, like it's not.
And granted, we just put the ice there, so I don't know how long it's been diffused into the air, the coolness of the ice. I mean, if we let it sit for 10 minutes, who knows if there would be a greater temperature gradient over the ice and in the air.
It's definitely. think your phone is ringing,
Yeah.
or my phone is ringing, one of the two. Hey, stop. It almost looks like it is directly over top of it or slight. Yeah. Directly over top of it, maybe slightly higher, which is odd. Front. Okay. Back is lower though, but it's higher than the control of back.
That's interesting.
That is interesting. I mean, it's slightly lower. It's like maybe a tenth lower
Then the control?
than,
Or then-
well, maybe not a tenth. That's like half lower. Than the original, yeah, throw the laser on again, but just verify. Where are you,
I
buddy?
didn't put it on yet.
Yeah, that's an on center. It's like slightly lower. I think she's calling again, man.
Yeah.
It's like dual call at a time. That's always been a signal with my wife that you need to like pick up. That's weird. Weird. Well, it's not as much ice. You don't have two bags on there now. It's gonna be in the way though. Yep, it's in the way.
Oh, well. Then my phone dies right at.
You need mine? You can use mine to call her.
Oh, you're filming on yours?
What's that?
You're filming on yours.
No, I got another one.
Oh.
Oh, it's somewhere. Oh, it's in my pocket.
It was like earlier, you didn't know you had it.
Oh, what's the passcode for this one? Okay. What is going on here? Big sister lessons. Okay. There you go.
Thanks, bud.
Just gotta go to the dial, I think.
Yeah.
There we go. Are we still recording? Jesus, it's been a half hour already. Okay. Okay. Okie dokie. So I gotta come. Oh, fuck! Singe the knuckle hair off there a little bit. Okay. Move it over. All good?
I couldn't get through.
Couldn't get through.
She wasn't picking up this time, so.
Ooh. Okay, I got the lighter going.
Oh, nice.
I think I have the beam kind of over it. I burnt my finger.
Did you?
When I was doing that, then I was like,
The lighter's
oh,
still
shit,
going.
yeah.
Okay. So, yeah, that's much better having that. big old head out of the way. I think that's going over the flame.
Yeah, we're losing that flame though, it's going down, so I don't know if this is gonna be a good test. So it is definitely remarkably higher. It's like 0.5 higher than the control and the cold.
And you can see it wavering too. As the
Yep.
flame's flickering, you can see the...
The aberration, which is a proof of rotation. Our aberration. Where's the green? Oh, it's right there. Okay. Green right there, 0.5. Fill it in. Okay.
It's a much better control of the flame than me holding it too. That could
Yeah.
have been some factor in us before, but...
Were you just holding it before?
Yeah, I was.
When we did the first one?
Yeah.
Oh,
Well, that's much higher.
it is much higher. If I could get it centered over the plus 12 y-axis. Okay, that's remarkably more diffused. But the center point looks like it's just a skosh higher, like it's wavering all over the place. I'm actually gonna mark it on a different axis. Like I'm just gonna go back here. Where do you like
Sorry.
Wait, how did it come down?
I'm sorry.
It was way higher before. Maybe that's fine.
I can see the, just like the heat waves over the flame is kind of moving all over the place. So it's probably,
Yeah. It's definitely higher than the control.
is it near where it was at front too?
No, it's lower than the front, but that's consistent.
Right.
That's consistent with all experiments. So I'm
Yeah.
gonna bring if you wanna hold the dot,
Okay.
bring the camera down. Back. So. What the now it's even lower still. What the fuck? But you can see that thing moving all over the place. It's got a plus or minus 0.2 movement.
Yeah, I just see the flame going left to right too. So
Yeah, it's got vertical plus or minus 0.2, and then left and right, it's got plus or minus 0.5.
Wow.
Okay. Well, I think we have sufficient evidence that you can bend lasers,
Yeah.
depending on what the laser is going over. So, you want to keep me in the... So what we were kind of hoping to do with this is to prove that when people shoot lasers over water, water is a giant heat sink, right? So it's going to be colder than the land in the summer. It's going to be warmer than the land in the winter.
Assuming your body of water is not frozen.
Correct.
Yeah.
But, now that's something that they probably should think about, is maybe doing it over a frozen lake.
There probably has been some over frozen lakes, but I'm not sure.
Huh.
I don't know if I've seen any or
That's
not.
something we could probably do here.
Yeah.
You know, it's just not going to be as long as distances like some other people have done. And you guys saw that we leveled everything beforehand. I don't really have seen much of that type of evidence with some flat earth videos when they're using lasers. Granted, we're only using like little laser pointers. Same class of lasers. We don't want to spend thousands of dollars on
Yeah.
something that we're just trying to do a proof of concept on. So,
Yeah. We had the
um,
control, and we had two variations, so we were showing
Yeah.
the effect with those.
So, yes, lasers will follow or will refract with atmospheric conditions.
Yep. And I don't know if I got much time to get into it today, but
Yeah, go ahead. Go right over your. You want me to hold
I
the
didn't,
camera while you go through the calculations? We can just move that right over. I'm just gonna go, I'm gonna go the long way around because I don't wanna crush a table, you know? Whoever thought of the Rogans, the Chinaman's limp for height? I came up with the Schumer, the measurement for weight, which is, one Schumer is 220 pounds.
So I wanted to go just a little bit over because I think what some people are, it sounds like some people, at least in the flat earth community versus, either people that think it's a globe or, within this discussion, some people are confusing the drop, ignore my completely ridiculous looking sphere Earth here, but
It's an oblate sphere void.
it's like a pile of silly putty I threw at the floor.
Yeah.
When, the drop of the Earth, which is tangent line from where your position is, tangent to the surface, and the drop is to wherever your object is located. So if you're saying, oh, your object is 100 miles away, your drop is 6,666 feet or something like that. That's the drop. What you don't take into account, or what you need to take into account, is the height of your observer and the height of your target. And so depending on your height, your elevation off of sea level, and your target's height and elevation off of sea level, a specific height of your target's only going to be hidden by the surface of the Earth. So,
By the curvature of it.
yeah, the curvature of the Earth, the surface of the Earth.
Assuming the
That
Earth is
a
curvature,
tangent.
part of it's gonna,
Yeah.
is gonna be covered. Okay.
Yeah. So when lighthouses have an effective distance of X amount of miles, you only need your light source of your lighthouse to be just above the crest of this tangent line to your height. So
So you can see the light that it gives off. Yeah.
So I don't have the math worked out here. I was just basically trying to prove the numbers. I didn't get through it enough, but in a later time maybe I can go through it all. But one point was Rowbotham's use of lighthouses to disprove curvature of the Earth. But I think his largest one that he used had a height of the lighthouse of 228 feet, and the effective range I think was 23 miles. And if you work out the curvature of the Earth, even if you're using your 8 inches per mile squared calculation, which isn't the real approximation of the curvature of the Earth, because the Earth is spherical, or assuming the Earth is spherical and you're using circular geometry, you're going to have some cosines and stuff in there, and you're using a parabola to approximate that. But whatever, it's essentially effective up to like 200 miles. They're pretty close. Plus or minus, like,
Then the
a few
model
feet.
is,
Yeah, the 8 inches per mile squared is pretty close to like 200 miles-ish. So within 23 miles of your lighthouse, you're going to be pretty close to your right number. And using your 8 inches per mile squared with a 228-foot tower for your lighthouse, I think your observer only needs to be 13 feet from the surface of the water. So a 6-foot person standing 6 feet off the water on a 6-foot boat or whatever could see that lighthouse at that distance. So that matches nearly perfectly with the globe math. So that doesn't disprove the curvature of the Earth. It actually goes right in line with it.
yeah. And that's kind of the thing that we were talking about. Like if the math works in a globe model or proves a globe model, and it's still valid in a flat Earth model, you can't use that as part of the proof of validity of one model over the other, because it holds true in both systems, which is what I was trying to get at.
Yeah. And I think even, I remember hearing David Weiss in DITRH channel, he was talking about that too when I've heard him do a couple of his debates where there's a few buckets, I think he called it, where you have the flat Earth bucket where your observation, your evidence, whatever it is, only works for a flat Earth. You have a globe bucket where it only works for a globe Earth, and then you have a bucket where it works for both. And so if it works for both, then you're not really having evidence for either model. So you
Right.
sort of neglect that.
Okay.
So this was just a brief test, brief experiments. I had to briefly go over curvature of the Earth versus the hidden of your target. And then hopefully we can maybe put out a little more stuff between
between myself, squatting flying bear and cowboy bear here. And
Cool.
you guys know.
Yep. All right. That's it. Remember,